Hi, welcome to my video on the 45, 45, 90 right triangle, part 4, primary trig ratios. And just a note, do the units on square root radical and the unit on the right triangular trig first. That'll make the simplification of this video, or the problem with this video, much easier to do. Here we go. Now we've memorized that our right triangle has 90, 45, so this angle is a 45. That means this side is in, this side is in, and this side is, in root 2. That's an in there. In root 2. I was almost going to write 2 root in. In root 2 are the sides. But if you make n equal to 1, you have a 1, n is 1, n is 1, and so this is 1 times root 2, which is root 2. So notice now, because the triangle 45, 45, 90 are all going to be similar, it's easier to work the trig when you have a 1, and just a root 2. That's the triangle that I have memorized in the 45, 45. Remember, that's a 45 there. So 45, 45, 90, I know this one, and root 2 when I'm working out the sides. That helps me. But if I'm doing trig ratios, primary trig ratios, or reciprocal trig ratios, then 1, root 2 is constant. I never forget these triangles right here. So, Sohcahtoa, Sohchahtoa. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So this is the trig that we learned in the right triangle unit, right triangular trig. So we're going to use it again now, but we're going to use it in the special triangle 45, 45, 90, as we did in the 30, 60, 90. So the tan of 45 degrees, tan is opposite over adjacent. So tan is opposite over adjacent. So the tan is opposite of 45 is 1, adjacent to 45 is 1. So the tan of 45 is 1. And it makes no difference which angle you pick, you get 1 over 1. The sine of 45, sine is opposite over hypotenuse. So the sine of either angle, you can pick sine is opposite, which is 1 over hypotenuse, which is root 2, 1 over root 2. But you can't leave a radical in the bottom, so you multiply by root 2 on the bottom, root 2 on the top. And that gives us 1 times root 2 is root 2. Root 2 times root 2 is root 4, which is a 2. And we leave it as root 2 over 2. You can't divide these. You can't cancel these out because that's a radical. That's an irrational number, and that's rational, or an integer. The cos of 45. Cos is adjacent over hypotenuse. So keep that in mind. So the cos of 45, adjacent over hypotenuse. So that's 1 over root 2. And you multiply top and bottom, numerator and denominator, by root 2 over root 2. 1 times root 2 is root 2. And root 2 times root 2 is root 4, which is 2. Notice the sine of 45 and the cos of 45 is the same value. Number 4, we have a root 2, and we got to work out the sine of 45. Well, the sine of 45 is already down here, so I have a root 2 over 2. So if you did go 1 over root 2 and simplify it like this, go ahead, but you'll end up with root 2 over 2. So that's root 2 over 1, and you multiply root 2 times root 2, root 4, which is 2. 1 times 2 is 2, and 2 over 2 simplifies to a 1. Number 5, the sine of 45 times the cos of 45. Well, the sine of 45, remember, if you think about it, the sine of 45 is opposite over hypotenuse, so that's 1 over root 2, and you multiply by root 2 over root 2, so that gives you root 2 over 2. the cos of 45 is the same, root 2 over 2. Cos is adjacent over hypotenuse. So 1 over root 2 becomes multiplied by root 2 over root 2 is 1 times root 2 is root 2. Root 2 times root 2 is root 4, which is 2. Both of them are simplified. Now we multiply the fractions. Root 2 times root 2, root 4, which is a 2. 2 times 2 is 4. And because we have a fraction, we try to reduce. 2 into 2 goes once. 2 into 4 goes 2. Simplifies. 1/2. Number 6. Again, we have the sine of 45. The sine of 45 is opposite over hypotenuse. So that gives me, and I know what it is, it's 1 over root 2 times root 2 over root 2. So that gives me 1 over root 2 over 2. Again, sine of 45, look up here, sine of 45 is opposite over hypotenuse, 1 over root 2, multiply root 2 on top and bottom. That gives me root 2 over 2. I didn't touch the 1 yet. Now 1 divided by, so that's the same as 1 divided by root 2 over 2. So that's the same as 1 times 2 over root 2, which gives me, and I'm going to go up here, that gives me 2 over root 2. 1 time. So I multiply by root 2 over root 2. So that gives me 2 root 2. Root 2 times root 2 is root 4, which is 2. And the 2's cancel, so I get a root 2. And if you think about it, 1 over sine 45 is 1 over. It means reciprocal of. So if you think about the sine of 45 to be 1 over root 2, reciprocal is root 2 over 1. Right there, root 2 over 1. Without working all this, again, you always keep simplifying. Number 7, the cos squared of 45. So that means the cos of 45 squared. And what's the cos of 45? Again, cos is adjacent over hypotenuse, 1 over root 2. And you multiply by root 2 over root 2. So we're going through this again. And that gives us root 2 over 2. And sometimes, if you can, 1 over root 2 becomes root 2 over 2. You memorize that. Like you memorize that the sine of 45 is root 2 over 2. The cos of 45 is root 2 over 2, because you have to simplify the adjacent over the hypotenuse, which becomes this, when you simplify it, is root 2 over 2. So root 2 over 2 times root 2 over 2, because I'm squaring. Again, root 2 times root 2 is root 4, which is 2. 2 times 2 is 4. And 2 over 4 becomes 1 over 2. I cancel out the 2's. Number 8. And the beauty of the 45 is that the cos and the sine of 45 is the same. So the cos of 45 is root 2 over 2. Now we've seen it being right here. We've seen it up here. So I worked it out once, so you can see why it has that. And we have to do the sine of 45, again, which is the same. You can work both of them out like I did here, and you'll come up with the same answer. Again, adjacent over hypotenuse or opposite over hypotenuse will give you root 2 over 2. Now, we had to simplify these first. Done. Now, we have to do PEMDAS, P-E-M-D-A-S. So we have to brackets, exponents, no. Brackets is fully done, no exponents, so we have to multiply or divide. So 1/2 times root 2 over 2 is root 2 over 4. Notice 1 times root 2, 2 times 2, 4. Subtract. 1 times root 2 is root 2, and 3 times 2 is 6. Now we're subtracting fractions, so the LCD for 4 and 6 is 12. So that means I multiply this one by 3 over 3, and I multiply this one by 2 over 2. When you do that, you get 3 times root 2 is 3 root 2. 3 times 4 is 12. Subtract. Root 2 times 2 is 2 root 2. 6 times 2 is 12. Notice we have the same denominator, so we write down that denominator, and we add these two. They're the same radicals, so this is 3 subtract 2, which is 1 root 2. Notice you can subtract these, but remember that's like a 3x subtract 2x, which is 1x. So we subtract these and keep the radicals, so there's a 1 right there. So that's the final answer when we simplify this. And that brings us to the end of working out the primary trig ratios on the 45-45 right triangle. Again, if you like my video, click the like button, click the subscribe button, and the notification bell, because there are more videos coming on different topics and units. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel, Math Fully Explained. Thank you very much for viewing my video. Bye-bye.